Xiaomi has unveiled an AI Cube prototype powered by 3 Xring chips to run large AI models locally without the cloud. In the next few minutes, we'll decode what each chip does, separate Xiaomi's claims from confirmed performance, and compare the Cube with NVIDIA DGX Spark and AMD Ryzen AI Halo. By the end, you'll know what looks genuinely impressive and which machine is practical to buy today. Xiaomi showed the machine on August 24, 2026. Mashable called it a multi-chip local-LLM powerhouse, while other reports focused on 3 Xring processors and the claimed 150-watt performance. But every reliable account describes an engineering prototype. Xiaomi has not announced a price, firm release date, or independent performance results. That distinction matters. We are reviewing an architecture and a direction, not a product you can order today. The unusual part is how Xiaomi divides the work. Xring O3 handles general compute and graphics. O100 is a near-memory accelerator designed to move model data quickly. D100 is the larger AI platform for bigger unified memory configurations. Xiaomi presents those 3 roles as one collaborative system rather than one all-purpose processor. Start with O3. Xiaomi describes a 3nm processor with a 10-core all-big-core CPU, 16-core G2 Ultra NX graphics, and a neural processor rated at up to 200 trillion operations per second. It gives the Cube conventional compute, graphics, and on-device AI acceleration. But these remain vendor specifications. We do not yet have Cube-level tests for prompt speed, thermals, or performance per watt. O100 creates the biggest headline, a 6nm 3D stacked design with 28,672 effective data lines and up to 1.22 terabytes per second of near-memory bandwidth. Near-memory is the essential qualifier. This is not a disclosed system memory result that can be ranked beside DGX Spark or AMD. It may reduce a major bottleneck, but until Xiaomi publishes the memory map and workloads, the number stays in its own lane. D100 is the scale-up piece, a 3nm chip with a 20-core CPU, 16-core neural engine, support for up to 160 GB of unified memory, and a claimed path to 200 billion parameter models. Xiaomi showed the Cube with a 120 billion parameter model plus a smaller 3 billion parameter model, switching between deeper work and faster responses. The aluminium enclosure has 33,874 precision openings. Impressive engineering, yes, but memory configuration, token speed, price, and ship date remain undisclosed. Hardware is only half of a local AI machine. Xiaomi already has visible work through Xiaomi MiMo on Hugging Face and GitHub, but that does not confirm which frameworks, model formats, quantization tools, or developer interfaces the Cube will support. The local LLM community is asking the right question. Does the headline describe usable memory, bandwidth, or something more specialized? Until Xiaomi publishes documentation and reproducible tests, the platform story is still forming. NVIDIA DGX Spark is a defined Grace Blackwell system. It combines a 20-core ARM CPU with the GB10 superchip, up to 1 petaflop of FP4 AI performance, 128 GB of coherent memory, 273 GB per second of bandwidth, and up to 4 TB of storage. NVIDIA lists a 140-watt GB10 figure and support for inference up to 200 billion parameters, plus fine-tuning up to 70 billion. Its larger advantage is a documented CUDA software stack and workflows developers can test now. AMD Ryzen AI Halo takes a different route. Ryzen AI Max Plus 395 uses 16 Zen 5 CPU cores, Radeon 8060S graphics with 40 compute units, a 50 trillion operation neural engine, and up to 128 gigabytes of unified memory. Its 256-bit interface gives a calculated theoretical peak of 256 gigabytes per second. AMD also lists up to 60 FP16 teraflops and a configurable range from 45 to 120 watts. It runs familiar x86 software on Windows and Linux, although Radeon framework support varies. In May 2026, AMD compared a 128GB Halo and DGX Spark systems at a 100 token context, averaging 3 runs. It reported leads of 14, 7, 12, and 4% in 4 local LLM workloads. These bars show only AMD's disclosed conditions, not a universal ranking. Side by side, the gaps become clearer. Xiaomi has the most unusual chip arrangement, but its retail memory configuration and measured throughput are not public. DGX Spark offers 128GB of coherent memory and the most established AI software path. Ryzen AI Halo also reaches 128GB, adds strong x86 performance, and can be attractive when Radeon support fits. Bandwidth does not belong on one winner bar. O100 describes near memory movement, while NVIDIA and AMD describe system memory. Product readiness is the clean comparison today. The Cube is a prototype. The others are defined commercial platforms.
Should you wait for the Xiaomi AI Cube? Watch it closely, yes. Plan a purchase around it today? No. If you need CUDA and documented model workflows, DGX Spark is the safer route. If you want x86 flexibility and the workload supports AMD well, Ryzen AI Halo may fit better. Xiaomi becomes a real contender after it publishes the Cube configuration, software stack, independent results, price, and availability. Its strategic importance is clear. Xiaomi wants to own the processor, accelerator, memory path, model, and local AI box together. Which local AI system would you choose? And what model should be tested first? Share your view in the comments. If this source-led comparison helped, please like, share, comment, and subscribe for the next review.